Hello everyone. Today we're going to start our discussion about hashing functions and hashing in general. So let's start with having one example of one array. Here we have an array of size 6. Let's say that you want to search an item in this array. What we usually do, if the array is sorted, we usually use the binary search to find the number. If the array is not sorted, then we are using the sequential search to find the numbers or the items that we have in the array. So here, assume that we are looking for the item for the index of the item that has the value 4. Because the array is not sorted, okay, so we have to start from the first item that is 7 and search one by one until we find the number 4 that is the one that we are looking for. So in this case, as you see, we need to, when the array is not sorted, we need to have, at the worst case, we need to have big O of n, time complexity for searching. Now we are going to see that what other data structures we can use for doing the fast and efficient searching. And the answer, one of the answer is using the hashing function and using in general using hashing concept. So next we're gonna see that what are the hashing. So let's assume that we have a table here that is similar to the structure of an array. So we have this table with the size 7. So the m that here in this case m is the size of the table is equal to 7. Now also we have the number of items that are already in the table, or the number of items that we have in the table. That here is n and is equal to 3. And also let's assume that L is the set of indexes that can be used for inserting the number items in this table that we have here. That definitely starts from 0 and goes to n-1, depending that, for example, which index we are starting from index 0 or 1. So the first index is 0 and the last index is n-1. And also assume that n0 is set of all possible keys, okay, that can be inserted in this table. That also the number of items that we have. So if the number of items that we have, the total number are going to be inserted, if this is less than the size of L, okay, then we are good because we can easily insert all numbers, okay, in empty places or the empty slots, and we are good. But what if the number of items that we're going to insert, okay, going to be more than the number of items, number of empty spots in the table that we have? So we'll discuss this later, okay, about the case that the number of items that we're going to insert, okay, is going to be more than the size of the table. So for inserting the numbers in this table, okay, or the keys in this table, we need to find a function that this function does the job for us. So because the reason for having these tables that we are calling these functions, these tables, hash tables, is to easily and quickly just search for an item in this table. So a function that maps an item to any empty spot or slot in this table called a hash function, okay? And we show it with the h. So if we have a function h that is the hashing function for for the key k, then it's going to give us an index, let's say I, that I is in this set L. That says that if we have a key k, then using some hash functions, it's gonna give us some indexes that says that in which location the new item will be inserted. And it's really easy also to search for an item. it's really easy. We are giving the key to this hash function, and it will give us the index I, and by accessing the item at location I, we can retrieve in the information that we are looking for. So the hash tables are a fast approach to retrieving the information, also to insert the information. We talk about hashing functions that is responsible for mapping in a key to some indexes in the hash table that we have here. So here we have an example. Assume that we have a hash table with size 4, so m is equal to 4, and we have this set of numbers that are going to be inserted in this hash table that are number 1, 2, 3, and 4. One simple hash function can be using a modulus hash function. So it means that we are dividing, we are getting the modulo of the number, the key that we have here, by the size of the table, that here in this case is equal to 4. So here our hash function will be h of k will be equal to k modulus of number 4. That 4, let's write it as m first. It's gonna be k modulus of number 4. So here, let's say that we have key is equal to 1. So when key is equal to 1, or k is equal to 1, then the modulus will be, or the hash function, okay, will give us this value for k of 1 will be 1 divided by the modulus of 1 by 4, that is equal to 1. So this gives us the index, so this is equal to I, and this is the index of like the item, the key to 1. So we are putting 1 here at this location, that is index 1. Similar to that, if we are calculating the hash value, okay, the hash, calculate the hash function, for key 2, it's gonna give us the index 2 and also index 3. And now we are gonna see that what's gonna be the 4, that is really easy. So hash value for number 4, or the key 4, that is gonna be the modulus of 4 by 4, that is equal to 0. And it means that it's gonna 4 gonna be at location 0. Okay. So now if we want to like to access or retrieve this information from this hash table easily, we are given the key. So let's say that the question is to retrieve an item with the key that is equal to 3. So again, we're using the same approach. Okay, we are calculating the index by seeing that what's going to be the hash, the value of the hash function for the key equal to 3. That is going to give us the index 3, so we can easily retrieve the item at this location. So now we are going to see that how we can come up with some hash functions. Okay, so here like the modulus function was was an example of the hash functions. So here we have like 2 steps. Okay, let's say that the keys that we have aren't numeric. Okay, so for non-numeric items, okay, the first step can be like converting them to numeric keys. Then those numeric keys can be converted. They can be converted to indexes, like some similar to what we had here. If we had here number keys 1, 2, 3, 4, and then we used like the hash function, like the modulus function, to convert them to indexes, as you see in this example. So next we're going to talk about these 2 steps. Let's see one of the ways, okay, to convert the non-numeric keys to numbers. One way is using the folding approach. So assume that you have some keys that are, for example, there are strings. We have some name. For example, we have some characters. Let's say that school. This is a string. Let's say you have a database of names, or like the words in a dictionary, and you would like to easily just find the words. So one way is, for example, here in this example, using the ASCII code of these characters we have here, and sum these numbers together. If we sum the ASCII code of these numbers, then it's gonna give us the number 648. So, and all letters in the word school are written in the lowercase. Okay, so that's ASCII code for the lowercase characters. Then we have converted the non-numeric key, okay, to a numeric key that is here 648, and then we can use another hash function, okay, a hash function to define the index for us. So let's say that we are using the modulus hash function, okay, and this m is equal to 16. Then what we need to do is just simply have this number 648. So let's say that h of key is equal to k, the modulus of 16. So here in this example for the school, okay, it's gonna be 648 and modulus of number 16, that is equal to 8. So 648 modulus of 16 was 8. So it means that we are gonna put the word school at index 8, and easily we can just access that by using the same approach for retrieving the information. But here is the problem. Definitely we can find other words, okay, that if we do the same approach, okay, so sum up all their ASCII codes and then finding the modulus by number 16, they're gonna give us the value 8. So it means that the hash function isn't important, like choosing the best one is important to make sure that we are not putting two words in the same location. So this is called a collision, okay, in the hashing concept, okay. So we're going to talk more about this collision and how we can avoid that, or how we can at least just somehow manage this collision.